Alright, 4th grade, one last comparing fractions strategy, and it's one of the easiest of all. It's only in a certain situation when you get really lucky. But anyhow, mark your last page as this, comparing fractions with the same numerator or denominator. It's going to be I think my last comparing fraction strategy. It's a nice one, but it only occurs once in a while. It could save you a lot of work, which is really nice. So when the special case comes up, I want you to know that you can justify your answer really easy without much work. So go ahead and write this down, unpause when you're ready, close your math notebook, and on we'll go. Alright, so I want to bring you back to the common denominator strategy. We already kind of talked about same denominators. If you'll remember, if I was comparing fractions like these, let's say, and I wanted to know, that's a 6, which of these fractions is greater, we kind of determined, well, this is hard to tell. And if they both had the same denominator, it's really easy, right? So we had this strategy where we said, all right, well, I can take 2/3, 1, 2, my 2/3, and I can partition it and turn it into 4/6 and say, well, if that's 4/6 and this is 5/6, it's obvious to me that 5/6 is more than 4/6, because if I wanted to change this to 5/6, I'd need another one. It's obviously greater. And so when they have the same denominator, it's really obvious which one's greater. And so that's actually half the strategy today, is once in a while you'll get two fractions that do have the same denominator or the same numerator, and then you can just kind of use common sense to know which one is greater and which one is less. Let's talk about it. Alright, so example number 1. Longhorn Steakhouse. They offer a steak that is 6/16 pounds and another one that is 10/16 pounds. Which one is bigger? I don't want you to feel like if you get a question like this and you say, alright, which fraction is greater, 6/16 or 10/16? It is okay for your strategy now to just be common sense and just say, well, I know 10/16 is more than 6/16, because since they have the same denominator, it is obvious that if I have something divided into 16 parts, obviously, and you wouldn't have to even draw it, obviously 6/16 is less than, I need what, 4 more for 10. It's just common sense. If the denominators are the same, it is okay to say common sense tells me that 10/16 is bigger. Now, there's also a trick you can do if they have the same numerator. Check this out. So this one says, they also offer 2 hamburger size choices, 2/5 of a pound and 2/6 of a pound. Which one is bigger? So now I don't have the same denominator, but I do have the same numerator. And there's a common sense trick to this too. If I make two exact same whole pieces. So just to be sure I'm like absolutely right, I'm going to even do that. I'm going to make one, and then I'm going to copy it and make a clone. Because I want you to see how this works. So if I have exact 2 holes, and if I'm really careful, and I cut one really well into 5ths, and I cut one really well into 6ths, it's hard to do. There's kind of a common sense thing that happens here. If I take the same hole, if I cut something into 6 pieces instead of 5 pieces, the pieces here are going to be smaller. It's just common sense because I'm cutting it into more pieces. So if I say, well, if I'm going to cut this into 6 pieces, and I'm going to cut this into 5 pieces, and I'm going to have 2 of each of them, obviously this one's going to be smaller because it's 2 smaller pieces, and this is 2 bigger pieces. it's kind of obvious without even making the drawing that 2/5, 2 bigger pieces, is going to be more than 2 smaller pieces. Right? So even without having drawn these, I wanted to draw these just to explain it to you. But I think with this, I could just kind of say, well, this is going to have smaller pieces. So since this is going to have bigger pieces and there's the same number of pieces, this one's going to be bigger. It only works because the numerators match. You know, I think of this as I'm really comparing, you know, 2 bigger pieces to 2 smaller pieces. Well, duh, the 2 bigger pieces are going to be greater than the 2 smaller pieces. So when your denominators match or your numerators match, your strategy to compare them can just be common sense if you want it to be. You can just justify it that way. So let's do one in your notes. Open your notebook. Let's do one of each. All right. So first, let's do a common denominator problem. It says at Mountain Park, there are 2 walking paths. One is 9/10 miles long, and the other is 4/10 miles long. Which is longer? So what I want you to write is I'm comparing 4/10 to 9/10, right? And I want your strategy to be common sense here. I'm going to even write it, common sense. Since denominators are the same, since the denominators match, 9 pieces is obviously greater than 4. This you wouldn't, you know, you could write this or you could even just think this. But it's obvious to me that since the denominators match, 9 out of 10 is obviously more than 4 out of 10. And so your strategy can just be like, duh, common sense. Okay? It works the opposite on this next one with the common numerators. So Harbin's Park, there are 2 walking paths. One is 6/8 of a mile long. The other is 6/10 of a mile long. Which is longer? So I'm comparing 6/8 to 6/10. And now, like I kind of said last time, okay, same numerator. I'm going to put that, actually I'm not going to write that there. So I'm going to say common sense again. Same numerator this time. And here's how I think about it. If I look at 8ths and 10ths, this is going to be, pieces are going to be smaller here. Right? If I take a whole and I cut it into 10 or I cut it into 8, these pieces are going to be smaller and these pieces are going to be bigger. Because I'm cutting it less times. So common sense. So same numerator. I'm going to say since 8ths are bigger than 10ths, 6/8 will be more than 6/10. If I have the same amount of 8ths and 10ths, since 8ths are bigger, I cut it into like bigger pieces, it's obvious to me that 6 out of 8 will be bigger than 6 out of 10. That strategy only really helps you in the very lucky case when your numerators match. But pieces will be bigger, pieces will be smaller. So if I have the same number, I have the same number of big pieces or the same number of small pieces. That's all there is to it. All right, so if you feel like you understand this, and once you have it written down, you're all set. If you don't feel like you quite understand this yet, and you want to go back and either watch the IDs or the WDs again and kind of think this through with me one more time, go ahead. Otherwise, you are all set. See you tomorrow.